Okay, this is my assignment 1 video recording for graphics game 370. So, first of all is the star, and when I run it, I have the star over here with the 8 triangle, or 6 triangles, 1, 2, 3, 4, 5, 6. So, to find the vertices here, just hard-coded them in, and the indices here, and had to change, the numbers for byte width, here and here, and then in the draw, make sure to do all of the triangles. So pretty simple. Next was the n-sided polygon. So right here I have numverts as a constant that is variable. In the init demo, you create all of the vertices here I just used sine and cosine math to find equidistant points based on the number of vertices. And then down here you actually assign the indices ordering and counterclockwise with counterclockwise winding. So you kind of loop through 3 at a time and map out the right triangle, or starting with that first one as the first triangle. So I had 6, and we get this 1, 2, 3, 4, 5, 6. Or if we do like, I don't know, 14 or something. We get 14. So that's working, I believe. In terms of the further work, for the first one, I actually had some pictures that I did for diagrams. So it was basically changing the z value of the initial triangle. So right now we're just hard coding the NDC values in this kind of cube that is the NDC, and you see the z-axis is 0 to 1. So when you put the top one back at 1 and the other one's at 0, this is the side view like of the z-axis if you think of looking at the cube that way. The top one is back there, but it doesn't matter. It doesn't affect the flattening of the NDC to the screen because even though it kind of seems like you're tilting that triangle back, the perspective of the camera isn't working because we're still just hard coding it into the NDC. We're not doing anything with camera perspective, so it doesn't affect the original image at all. And then when you that's the last one. The second one was when we had the z value equal to 2. And we got this weird trapezoid. What's happening there is that the top vertex is actually outside of the cube that is the NDC. So it's way out here. And the only stuff that you're flattening to the screen is this kind of bottom half of the triangle. So that's why it kind of cuts off the triangle right there, and you only get that bottom half. And once again, you're not getting that perspective because we're just hard coding the NDC value. So it's just going to be exactly halfway on the z, or just halfway where the triangle is cut in half, and you kind of get that trapezoid shape. And then the same kind of thing is happening. This picture is not good. I couldn't really figure out how to draw it right. Oh shoot, that's the same one. This picture is not good, but basically if you put both the top and the bottom right vertex outside of the NDC box, they're both way out here, then kind of think of your triangle tipping way back, and so the only part of the triangle that's actually inside the cube at that point is just this tiny little triangle in the bottom left, so that's what you see when you put both of these with a z value of 2. So hopefully that's sufficient. And then for the last, there were 2 more. First one was resizing the viewport. So when I did that, at first I kind of thought that the triangle would shrink to still fit inside the window, but all it did was just shift. Once again, it's because we're just hard coding those NDC values, and they're not going to change proportions dynamically. We hard code them in. So when you're just changing where the viewport starts, they're just going to shift, and the triangle kind of goes off the screen. In terms of when this would be useful, the first thing I thought of was a little mini map. So maybe like HUD elements at large, you could kind of position them at different places on the viewport. I guess you would need different rendering pipelines going on, like one for the main game and then one for the HUD. I'm not quite sure about that. And then another thing I thought of was a split screen. So if you had a local multiplayer, 2 people playing on the same screen, maybe for the player 2 rendering pipeline, you would shift so that it only renders, starting on the one half of the screen. So those are some ideas that I had. In terms of these DXGI formats, so the first one is in plain English, kind of, it's a 4-component, 32-bit unsigned normalized integer that supports 8 bits per channel, including alpha. So there's the 8 channel, the R channel, which is 8 bits, G, B, and A, alpha, which are all 8 bits. In terms of they're unsigned because colors don't need to be, like, negative colors aren't really useful. You just have the color ranges as positive, you're like 0 to 255 or whatever it is. And then normalized, still a little confused about this, but according to the research I got, so normalized is when you can store an decimal as an integer, basically. So you basically have these 4 integer values, but then OpenGL which is where I got this info, so I'm assuming DirectX is the same thing. It'll convert to and from floating point values. So basically you can use like a 4-channeled number, but then the computer will convert it to a floating point. So like each color will actually just have a floating point number associated with it. And this is useful in the context that we're using it, because we're using it for the buffer description for the swap chain. So the swap chain is responsible for like reading textures, like we said, and swapping back and forth between them. So when you're reading a texture, textures are usually formatted with the 4-channel colors. But when the computer is processing it, I assume that, just imagining those 4 integers as one floating point number is more helpful. So that was kind of my understanding of this one. And then for the R16 unsigned int, this is a single component 16-bit unsigned integer that supports 16 bits for the red channel. So red doesn't actually have to do with it at all. It's just that it's a single component, as opposed to this one, which had 4 components. This is only one number. And this is relevant because we're using it in the setting the index buffer. So basically we're describing what the index buffer is, what kind of format it is. And the index buffer is just a list of integers that correspond to the different vertices. So like for our triangles, the vertices are each 3 floating points, and each of the integers is just referring to one of those. So it basically just needs a sequence of numbers. It doesn't need more than one channel, so it just uses the first channel or red channel. And for this set index buffer, you only have the option of either 16-bit or 32-bit, so whichever range. I don't really know why you would need 16 versus 32, like if you needed a bigger range of integers for some reason, but the bottom line is you just need like one integer to refer to each of these vertices. And then it's unsigned because there's just no reason to have signed. I don't think the negative numbers wouldn't mean anything. You're just trying to point to these vertices, so you only need the positive range. And then sint would be a signed integer. I don't know where you would use those, but I'm assuming we'll see them later. So that is all I got for my video.